from all kinds of different aspects of the ecosystem of blockchain technology, and I think it will be super interesting. And yeah.
All right.
I'll give the word to our first speaker, Lukas.
Thanks. Yeah, hello. Welcome everybody. My name is Lukas. I want to give you a quick technical overview about blockchain technology. Who of you has heard of blockchain tech? Oh, okay, I don't have to ask it. Who would say he has a basic understanding what it's all about? And who considers him an expert in? All right, nobody. Then that's good. If you have any questions during the talk, please feel free to ask them. We will be talking about the basic ingredients of a blockchain. That's ledger, transactions, the peer-to-peer network. Then the cryptographical basics, that's two things, hash functions and digital signatures. And then the consensus algorithm, which is basically the invention. I can't go into very much technical detail there, but we will take a look at it. So let's start. The first thing is the ledger. The ledger is this book. You can think of it as a book which contains all the information about a business or about what you want to do. So, for example, if you're running an insurance, the ledger would contain who has what insurance policy, who is making which claims, and so on and so on. If you are a bank, the ledger would be which account has which balance, and so on. The ledger is created from a Genesis ledger. That's basically when the ledger starts, it has a certain state, and the state of a ledger is changed by transactions. Transactions are some input that change the ledger. Yeah. Okay. At the moment, yeah.
This ledger, is that one book or ledger per transaction, per entity, or?
No, it's one book per business entity. So you can, in a business sense, you can think of it as a balance sheet. So there are the balance sheet, there's a balance sheet of a company, and then there are different transactions that change the accounts in the balance sheet. Okay, at the moment we have mostly centralized ledgers, which means some central entity in the middle has the ledger, is in control of the ledger, and all the clients around this central entity are sending requests to the ledger, give me some data, change this, but the clients here don't have a direct connection. If you make a wire transfer to your neighbor, you send a request to the bank to change the ledger so that you have less money and he has more. There are some problems with this client-server architecture. That is mostly you need a trusted third party. And this server in the middle is a single point of failure. That means if the server is out, your network is gone. It's over. If you lose one connection if you lose your connection to the server, you're out of the network. These client-server architectures can be layered, so you request your bank to wire some money, and then the bank requests a central clearing station to wire the money to the other bank and back to the account. But that's still a centralized ledger because there's one single entity on top of it. Okay, the other model, that's the new model, is a distributed ledger, which is in a peer-to-peer network. In a peer-to-peer network, we eliminate the central server, and we have peers with equal rights that are connected with each other, and every peer in this peer-to-peer network has its own ledger. Everybody in this peer-to-peer network looks into his own ledger, and when you have a transaction, you send this transaction to your peers you're connected with. This is basically a robust model, so if you cut one connection, you're still in the network. If one node is out of the network, the network is still operating. And all right, first let's take a quick look at such a peer-to-peer network. That is the live map of the Bitcoin network. The Bitcoin network is a peer-to-peer network, and you can see there are all these nodes in this network, and they come and they go, and they are not forced to stay, so they can basically do whatever they want in this network. So you can see here some different clients and some different hosting regions and stuff like this. But I just wanted to show you how such a peer-to-peer network can look. And
does it tell me now that there is?
So there is this node in Shanghai, and now it's gone, and these nodes are coming and going. It's not a fixed network. It's just if you start your node, you connect to other peers, and when you turn off your computer, your node is gone.
So they're switching on and off their computer in seconds?
No, not in seconds. That's you can run your node as long as you like. Yeah. Okay. So now we have to look into some technical stuff because it's good to understand some cryptographic details of blockchain technology. There are two things we have to take a look at. The first one are cryptographic hash functions. The cryptographic hash function is like a data meat grinder. You put some data in, and there comes this cryptographic hash comes out of it. The important thing is if you put the same thing in, the output is always the same. And if you change only a little bit of the input, the output of the hash changes completely. So it's like a digital fingerprint of a piece of data. You can pull every piece of data from the internet and put it through this hash function, and you will have a fingerprint of it, and you can identify data with this fingerprint. So you're pretty sure, or you are sure, that this, when you see the hash and you put data in, that it really was originally this data that was inputted. So hash functions are used for a long time exactly for that, to prove that some data is original. So you download something from the internet, and you know you want to have this hash data with this hash value, and then you can check that you really have the data. And yeah, that's one important cryptographic for blockchain technology. That's the technology that will later link the blocks with each other. The second important concept is public key cryptography, also known as asymmetric cryptography. That's an invention from the 80s. The concept is that in symmetric cryptography you have the same key for encryption and decryption. Here you have different keys for encrypting and decrypting. So you can encrypt your data with one key, and decrypt it with the other. And it's important how this key pair, this private key and the public key are a key pair, and this key pair is generated from a big random number. So you just put on your random number generator, pick a random number, that's basically your private key, and then you have a public key function that makes a public key from this private key. The public key you can publish all over the place, everybody can have it, and the private key you should really keep in private. That's your secret, and that's important for one aspect of this private public key cryptography is using it for digital signatures. That's what we're doing in blockchain technology. That works like this. I can, as a sender, I can sign a message with my private key. Then I send the message to anybody out there, and all the receivers can verify that the data is coming from me by using this the verify function, and therefore you need the public key, and you can not only verify that the data was not manipulated, but you can also verify that the private key corresponding to this public key was used in the signing process. Okay, that was yeah.
Doesn't it imply that everyone can read whatever is said? So where's the confidentiality aspect of it?
That's right. If you don't encrypt this message, everybody can read it, but nobody can tamper with it. So you can change the message, but you can read it, because when you change the message, this signature won't match anymore. But you're right. There's it also works the other way around, that you can encrypt it with a public key, your message, and then only the person with the private key can decrypt it. But you're right, here it's not encrypted. Yeah.
There is an EU regulation regarding digital signature, the EIDAS regulation, which works nearly the same. Can you reflect that?
I know about the German part of it, that's a qualified electronic signature. Basically, what they use is exactly this mechanism. There's only one part. There's a certificate authority that authenticates this link between the person and the public key. Because exactly, they issue you go there with your papers, and they issue a certificate that this public key is really of this person. Yeah. And then you can make qualified electronic signatures. And that's a good point, because in the blockchain world, we don't care about all right, I will explain that later, because first, I'll explain it yet. In the blockchain world, we don't care about the people behind these keys. In the blockchain, the keys are the identifiers. They are the accounts or the IDs. These public keys are used as IDs in the ledger. So we don't care about the people behind the public key, and therefore we don't need this certificate authority, because the key is all you need in the blockchain. So then we have this peer-to-peer network where the public keys are the IDs, and the peers in this network, they sign their transactions corresponding to these public keys. So every peer in this network can authenticate that the sender of this transaction is really the holder of this account in the blockchain. The receiving peers verify that the transaction really comes from the sender. And the most important part is you really have to keep your private keys. The private key that is corresponding to the public key, that is the account in the network, is the only thing you can retrieve the funds with. There is no phone line, there is no pope, there is no court, there is nobody who can retrieve the funds for you when you lose your private key. And you can make a public-private key pair just by picking a random number. So you can pick as many random numbers you like and have as many accounts as you like. And perhaps speaking about numbers, we're talking about really big numbers. For example, there are about 2 to the power of 180 Bitcoin addresses. It's like the number of atoms in the Milky Way or so. So don't worry about if somebody accidentally picks the same random number as me. That won't happen.
The public key is based on the private key and is arrived at by way of mathematical operation.
Yeah.
Why doesn't it work the other way around?
And that's called a one-way function. So basically, like similar to the hash function, you put data in, and there's no way back in this mathematical function. The function is called elliptic curve digital signature algorithm. That's too mathematical for here. And to be honest, I don't even fully understand how this works. It has to do with discrete logarithms on an elliptic curve, and yeah, that's complicated. All right. So now to the blockchain. You see the smiley here. I talked for 15 minutes. Now let's come to the blockchain. So now we have this peer-to-peer network that is floating around, where these transactions are floating around. People are sending transactions and receiving and relaying them. And now in this peer-to-peer network, the transactions are stored into blocks. And a block is just some basic data, a timestamp and not another number, and this number here is just all the transaction hashed together. So the information of all the transactions is in this number here. If you change one tiny thing here in one of the transactions, this number change, and because every block has the hash of the previous block in it, if you change something way back here, a tiny thing, it changes the hash function in this block and in this block and therefore in this block, so it's immutable. Or not immutable, but immutable without noticing. So if you change something way back, we will notice it today because these linked hashes follow through the chain. Okay, that's the blockchain. Please don't. What is done very often is to use blockchain and ledger synonymously. It's not. The ledger is this book, and the ledger is held locally. The blockchain is just an ordered list of transactions. So the blockchain stores the transactions, and the ledger stores the state. That's an important. Okay. Now yeah, I can't really go deep into this one, although it's really the most important or most revolutionary part, and that's the consensus algorithm. So by consensus, it means we have all these peers all over the world, and how do we make sure that every peer has the same understanding of what the actual state of the ledger is? That's really difficult. That was the main part of the Satoshi Nakamoto paper and the Bitcoin invention. And there are different, today there are different algorithms to do this. The main algorithm is today and was proof of work. That works like, yes, somebody has to decide the order of the transactions. If you throw two wire transfers, send two wire transfers to your bank, the bank has to decide the order of the transactions. Because the transactions can mean a totally different thing if they are in a different order. So somebody has to decide, so one of the peers in this network has to decide for every block in which order this transaction. And there was this elegant algorithm, this proof of work algorithm that can do this. And that's the part with the mining and the wasting of lots of electricity you heard probably about. But I want to come to the, I don't have much time left, so I want to go to the smart contracts. And the original, or the most common platform for smart contracts at the moment is Ethereum. And in Ethereum, you have the so-called Ethereum virtual machine. And this is really a tricky invention because 4 years ago, Vitalik Buterin and Yanis, who will talk later, thought about it, and they thought, why only store the account balances in the blockchain? Why not store a state of a computer in a blockchain? And that's what they did. So in Ethereum, the ledger not only stores the account balances as in Bitcoin, but also the state of a virtual machine. That sounds complicated for non-computer guys. Perhaps you can, you know what a virtual server is. It's just an operating system on a real machine, and you can store everything of this machine, of this virtual machine, on your hard drive. And as you can store the state of a virtual machine on a hard drive, you can store it in the ledger as well, in the ledger of a blockchain. So that's what Ethereum does. And so all the peers in the network run this machine, and calls to this machine are transactions in the peer-to-peer network. And what you can do with it is basically programmable money. So you can make a code, and this code can decide who gets how much money under which conditions. And these codes that decide who gets how much money under which conditions are called smart contracts. Because for a programmer, a contract is nothing more than a piece of code. It says who gets what under which conditions. There's also a fee involved for using this virtual machine that's called gas, but that's the technical part, and too much here, and I already see I'm short on time. Okay, so there are two basic accounts in Ethereum. You have this, it operates like a normal cryptocurrency, like Bitcoin, and with the addition of smart contracts account. And these smart contracts are governed by the code that is stored in this smart contract. And you can send Ether to this smart contract. The smart contract can call other smart contracts, and it's what the programmer would say Turing complete. That means basically it means programmable. So you have this programmable money, and yeah, what can you do with it? There are a lot of prototypes. This is how such a piece of code would look like. It's a simple auction. You can have conditions on who can bid, how much, who is getting the reward later. Or you can basically, it's a programmable computer. Yeah, you can pretty much do with this code whatever you want. There are some. This is future stuff, or that's current work. There are a few problems. We have to get rid of proof of work. It's energy, it's just a waste of energy. And there's some other ideas to make blockchains better, bigger, and scalable. I can go into these right now. Is there something left? Yeah, other blockchain platforms. There's a whole zoo today of new blockchain projects, blockchain platforms. There are consortium chains, there are side chains, there are state channels. It's really a lot of platforms, a lot of stuff, and a lot of to keep track of. I'm being told I'm out of time, so yeah, thank you very much. Do we have a short period for? No, we don't. Okay.
Okay, thank you, Lukas. So I think you got an impression of what are the fundamental building blocks of the blockchain, and I think you also got the